I think we should probably start off with a round of introductions. I think we have quite a diverse crew here, different backgrounds, different areas of expertise. And I think there's a common thread that you all share, and that is you're all involved in developer tooling and sort of building these tools that have this multiplying effect. So I don't know, Brooklyn, do you want to start off?
Sure. Test, test. Yeah, okay. I just have to hold it much closer to my face than I thought. I'm Brooke. If you were around earlier, I'm Boris's co-founder, and I'm working on Fission. We provide sort of a whole suite of developer tooling from a publishing platform initially, and then realized that we need to actually move down a few layers and start fixing and changing and adapting data transfer protocols we were just talking about, and encryption in the file system, and UCAN, and a bunch of these other things. So we've ended up becoming a bit of a protocol house as well.
Good morning, everybody. Hi, I'm B5. I work at a company called Number Zero, and we make a tool called IRO, and we're on a mission to make the most efficient implementation of IPFS on any planet. This one's the most important one for obvious reasons. But yeah, I came to this because I originally started a company built on top of IPFS, and I'm now trying to build the version of IPFS with our team that I wish that I had when we started, and make something that is really focused on application developers and solving some of their pain points when it comes to working with highly distributed technologies.
Cool. Hi, I'm Carson Farmer. I'm with Textile, and I already knew this, but listening to my fellow panelists describing their sort of like how they got and why they're on this panel today, literally the exact same reason. Textile has been around for quite a while. We started trying to build a consumer app on top of IPFS on mobile, and then we said, oh, geez, that was hard. So we went down a stack and we started building developer tooling, and then we're like, well, that was hard. Let's go down a bit further, and now we've started developing sort of more lower level protocol tooling. And so that journey is obviously one that you just have to do, and it's a bit of a battle, and then you sort of find a good spot somewhere lower down the stack and start building there, hoping that someone who comes along after you has a little bit of an easier time. So yeah, same journey, and here I am.
Hi, I'm Sara. I work at Infura. I'm going to break ranks. We haven't built on top of IPFS. We just provide RPC access to IPFS. So yeah, we want to, obviously we want to make the developer experience as good as it can possibly be as well. So I'm really on this panel just to learn.
Great. So I think one of the very first questions that I have for you is, what do you think is the most important missing building block for building on top of IPFS?
Can I take this and set you up for success? Because the answer is encryption and access control.
Encryption and access control.
And do you make anything that helps for that?
We do. Several things. Web native file system gives you encryption at rest and a granular access control within that. So single file or entire directory. We're rewriting it in Rust currently in WebAssembly, so it's going to run literally everywhere. A distributed database with the same properties. So if you don't want file system, you want database type things, we'll be able to do that quite soon as well. And UCAN, which I'm really happy to see showing up in a fair number of talks, is totally decentralized auth and trustless interoperation. That is hopefully going to find its way into things like IPFS nodes directly, and then we will be able to plug all of our systems together without having to do pre-negotiation and figure out all of these APIs and systems.
Thank you. Any other?
Yeah, I mean, if you think about IPFS as this sort of infrastructure, or even if you take its name literally and call it a file system, then you can imagine, well, what are all the things that are on my file system that I don't have yet on IPFS? And it's everything, I guess. So it's databases, it's applications, it's all of those. It's like IDEs and developer tooling. How many IDEs do have integrations for IPFS yet? Probably zero. So it's all of those things that I expect on my desktop, I think we're slowly going to start to see those things bubble up as useful tools, as part of the IPFS stack. So, yeah, lots of things is my answer.
Thank you. So if we back up a little bit, a lot of the decentralization space is not purely focused on IPFS. There's other solutions. I mean, it's hard to not mention blockchains. And I think one of the first questions that developers are confronted by is, do I need a blockchain for this? I mean, blockchains are extremely expensive. They don't really offer a lot of space. So to sort of simplify the question, how do you know as a developer if you need a blockchain?
Well, that's a big question, isn't it? As a developer, do you need a blockchain? So I guess, yeah, I mean, as an IPFS developer, no, of course, it's a completely separate network and it's chain agnostic if you do need a chain. But I guess I just spring to mind all those flow charts that you see, do you need a blockchain? And invariably, they resolve to no. But I think if you want to have some kind of single source of truth or something that does have this kind of cryptographically secured state that needs to transition, then yes. If you just need a snapshot in time or something that's entirely mutable or doesn't matter with all of those features, then you probably don't need a blockchain. Safe space, right?
I mean, I have a cheeky answer, which is like, just ask your investors, and they'll tell you yes, and then you have your answer. But I think the real answer is, yeah, if you need, if you need, strong consensus over some state, then maybe it's a good idea, especially if that consensus needs to be sort of trustless and driven by not a top-down consensus, but otherwise probably not. And certainly you should not be putting like anything that shouldn't exist forever on a blockchain. So don't put personally identifiable information on there. Then the rest is just build your app with the tools that make a lot of sense. And if those tools don't exist, you can come and join us and build them.
So what do you think are some of the most common misconceptions about building apps with IPFS?
Probably that you need a blockchain.
You should say that in the mic for.
That you need a blockchain.
Any other ones?
That IPFS is a file system.
Great, I love that one. So what would be your description of IPFS?
IPFS is a really great discovery and transport protocol. It is not in itself storage.
Yeah, actually, I'm going to double down on that. I think that's the hugest misconception about IPFS. And to be honest, it sort of bugs me when people are like, yeah, no, I put it on IPFS. You're like, no, you made it available over IPFS, or like you announced to the network that you have something, but you didn't put it on IPFS. And unfortunately, that's just like nomenclature that we as an ecosystem use, and it's very confusing for end users. And as a team of developers that build IPFS-y type things, a lot of time I'll get a new person to the ecosystem come and they're like, yeah, no, I'm building IPFS. I've got this app, it's going to work great because they're using localhost 3000, and it does work great. And then they're like, no, it's on IPFS, so it's just, and then you have to explain to them like, well, you probably need to use some sort of pinning service or like a public IP address that's routable and blah, blah, blah. And you start to explain those things, and then they think, well, this guy just doesn't know how to use IPFS because I've got it, it works great. And so then they slowly discover that actually there's some intricacies, and then they come back to you later and they say like, oh, well, I wish you would have told me this before. And that's a part of our job as tool developers is to try and like smooth over some of that stuff, make some of that stuff more obvious, and just like sort of clear up those common misconceptions. But Brooke is 100% right. That's the biggest thing, is not a storage, it's a discovery and transport protocol. And if we get that across really clearly, then it makes it so much easier to develop on top of, because you keep that in mind, like, okay, it's like HTTP or it's like something else. So yeah, that's what we can do, I suppose.
Hello. I would plus one all of that and add to it that I like to think of this in terms of like the evolution of our space a little more broadly, temporally. You're hearing it from a group of panelists who are saying, hey, we all moved down to try and help people coming up. Like, hopefully that doesn't happen forever, right? And we're now starting to see this whole story get a little easier. And so I think it's great that the people you're hearing from here are teams that have moved down to try and solve problems for people above them and are all very concerned about the messaging, because that's going to be the last piece to really land, is like, how do we align on clarifying to people, hey, this, like, the way this should end is really should look similar to like the emergence of React, right? Like, it's like, cool, you follow this tutorial, this is how this works, and the number of people who have put time into removing all the foot guns from that tutorial and making it such that it's like, okay, cool, and last step is choosing your pending service because you need one of those type thing, is ideally where we end. That, if we thinking sort of in the macro time scale, that's starting to emerge now because we as a network of teams are starting to learn how to work together to build that, which is exciting, and I think really one of the watershed things that comes out of conferences like this. But my expectation is that next year we'll ideally start to see some of those tutorials emerge, and those will be the product of cross-organization collaboration saying, I don't know, I've talked to the people, we need to really explain IPFS differently, and we really need to have a conversation about how people deal with persistence. And, someone's just figured out how to make the whole NAT traversal problem kind of go away in a way that, we're finally getting hole punching happening at a rate that's effective enough that this is just less of an issue, so we can kind of skirt around that one. So ideally, that's where we see this evolve, but that takes collective effort for all of us to do it, and hopefully that's where we end. Or at least not end, where the next step.
Where we begin.
Where we begin. Where we begin to begin again. The brand is so, we're not at rsync.conf, we're at IPFS Camp. It's all in the name.
It's pretty nice name though. And I was just talking with Brooke earlier, and I was like, I kind of wish they'd named it like Interplanetary Transfer Protocol, but IPTP sounds stupid. So let's just stick with IPFS and just be better at describing it.
Yeah.
So how do you see the relationship between IPFS and HTTP playing out over the next year, or the coming years?
Yeah. So HTTP is a single, point-to-point transfer protocol, right? Maybe uncontroversially focused around hypertext. It's in the name. There's nothing saying that we couldn't add HTTP as a libp2p transport. It's a thing we could do, right? It's a thing that my team is literally working on, because if you want to support browsers, you need to use some mature transports sometimes, right? Browser's not dialable. It does a really great job of client server today. So what if we could just go and say like, hey, other node, just give me data, and not over a HTTP gateway. Yes, we'll use HTTP, but like, let's still maintain the IPLD graph as we're pulling in car files, things like this, right? So I think that in the next year, and actually we were just talking directly before the panel, I think this keeps coming up as a theme, of a bunch of us need really efficient transfer protocols that work on synchronizing graph data. And one way we can do that is to push it over HTTP. So I don't think that it's an or, it's an and.
I think the thing your question is hinting at is which part is the IPFS part, right? It's like, how do we feel about HTTP? Because do we have to move it over libp2p for it to count? And is that part of what it's getting at?
Part of it, but also the other part of it was one of the most common ways to use IPFS by newcomers is IPFS gateways. And so we've improved the specification. There's been a lot of work there. We're discussing writable gateways. So it's like HTTP just seems to come up everywhere you look.
So on the topic of gateways in particular, I think that if we upload over HTTP to a server and we download from a server, and it's the same server, we've created an Apache server with extra steps. So we need to have something that's a little bit smarter, that knows about graph data, that knows about IPLD, that isn't just LARPing decentralization.
Spicy, spicy.
That's what we're looking for on panels. Nice. I wish I could disagree, because then that makes it even more exciting. But
I can disagree. Do you want me to disagree?
Sure.
I'll disagree. I think that the only thing I don't disagree with the point. I disagree with where to put the what counts as IPFS. I think as long as it verifies the hash locally, that's what I care about. Because from that's the thing that we can say, cool. If I take 6 gateways and I fetch randomly from all 6, as long as I'm confirming that the thing I got matches the thing I asked for, to me that's content addressing. Do we call that IPFS? I don't really care. But and I think that's the pattern that I want to really push to application developers. The crucial thing you need to do for it to be decentralizable or distributable, to pick your buzzword, is you need to fetch content and check that the thing you got is the thing you asked for. And that's to me is the thing that, if I could only say one thing to application developers, your system needs to do that. I'm less concerned about the transfer protocol. I'm more concerned about the characteristic of hash integrity.
Okay, so on that front then, so how many people here use Brave? Good chunk of people. So Brave has an embedded IPFS node, which is really just a local gateway. And so by that logic, does that count then? Is that good? We're good there? Yeah, cool, okay. I think that's a good answer there too, is as we see IPFS nodes becoming more ubiquitous on the edges, then it starts to replace HTTP. And I'm always sort of a little excited when I go to a website and then I notice that it sort of flips and shows me my gateway address locally. I'm like, yeah, it worked. That's cool.
What's the tool that you used to flip to go through your local node?
Can you repeat the question for there?
So just to repeat the question. The question was, how do you know that, what tool do you use to know that it flipped to your local node?
So with Brave, if I have my little toggle for IPFS turned on, and I have an IPFS node running, you can use the embedded one, or I have IPFS desktop, so I think I default to that one. It just works.
What? No.
Yeah, but it's DNS Link that's doing it, yeah. Is the technology that's being used, yeah. But also, yeah, just do it, it works.
So what do you think are some of the inherent trade-offs that are here to stay with us as developers, application developers building on top of IPFS? I mean, there's certain costs. As per your definition, it was verifying locally. That's quite expensive to do, especially if we consider, low-power devices. I'm sure, we can come up with better, hashing algorithms, perhaps, and more optimizations. But what are some of these inherent trade-offs that, an application developer who's looking to build these decentralized apps, what should he take into account?
So in the long term, I think that we can get to a place where it is not just at feature parity, but significantly better, where you've downloaded data recently, you don't have to go back out to the network to fetch it again because it has the hash. Or the dream that we all have, I think, is you're sitting next to somebody at a cafe, they have a news article up, you load the same news article, and it just goes direct from device to device, right? That's future vision, right? Today, everything is so early, so the trade-off is there is no one way of doing things, and you try to build an application, and immediately you end up on this panel of people who've had to drop down a few layers.
It'll happen to you too. It'll happen to you too. Be careful. Yeah, I mean, that's a good point. And whenever I try to explain how the internet works to my mom, and I've got my phone here, and she's got her phone, and she's like, "Well, I want that picture on there," and I'm like, "Well, I can't just send it directly to you." She's like, "We're physically next to each other. Surely that's how the internet should work." So that's the sort of intuitive thing, and it is true that it's going to be a while before we get there, because I have to explain to her, no, it goes to somewhere in maybe like Chicago or Cupertino somewhere, and then someone does some work over there, and then they send it to you, and it's like, it's this insane network of tubes, yeah, internet tubes, which can get clogged, right? So, it's avoiding that clogging is what we're after. And that's how the internet works.
And I think that people today are coming with a bunch of biases of 30 years of the internet and the way that's worked historically. And even this idea of the data lives in one place, like the data is over here and I can update it, and then we all read the latest single source of the truth data, and that is already a lie as soon as you do replication on a database or whatever. So we're going to have to change how we think about things to be like, oh, right, this is all, we want this, even the caching that I mentioned earlier is cached locally. Okay, well now it's eventually consistent, right? There is no one single source of the truth. There are many sources of the truth. There's an infinite number, and my data might look slightly different from your data for now, for some number of seconds or minutes, or maybe I'm completely offline, I'm on a plane, and the Wi-Fi is terrible, so I just turn it off, and I should continue to be able to use my app because I'm on IPFS. But now I'm diverging from everybody else. And so coming with it from a different mindset is something that's this community and I think the web in general, as we start to adopt these techniques, are going to think about things differently.
So this leads me to the next question. Many of you shared the belief that encryption is one of the missing pieces for IPFS and for doing any kind of thing that involves PII, personally identifiable information. So in 5 years from now, how do you think users will manage their keys? I'm sure that you have some opinions about this, but yeah, let's take that question.
I would love to hear from anyone else before I go on a rant.
Rant, please.
Yeah, go for it. So PKI is getting better really fast. So even in, say, the Web3 space, people have their MetaMask wallet, and that's about 50 million users today, and they're already coming with their keys. They're already doing key management. Amazing. With things like passkeys, which is Apple, Google, Microsoft, and a few others, and it's just built into browsers now. You have key management without passwords in all of your systems. And that is for doing signing, both of those systems, right? I'm going to sign some data. There's work happening at the Chain Agnostic Standards Alliance, CASA, for standardizing encryption decryption with wallets. And we have the Web Crypto API in browsers for doing key management. I think the real techniques are around how do we manage as few keys as possible while giving people access to as much data as they can have. There's a great quote from Google, which is, the great thing about cryptography is it turns all problems into key management problems, which is terrifying because key management's super hard. But if we can reduce the scope of that to say, you just need to keep this one key, and then you'll have access to whatever you have access to, and we can do, hierarchical encryption and all of these other things. Then it just makes it much easier. And we have this abstraction layer now where we can say yeah, this is stored in in a hardware wallet or directly in the browser or on a piece of paper where you type it in every time, or we derive it from a passphrase. It doesn't really matter anymore, and we can make this much, much, much easier. The hard part of all of these things isn't where we keep the keys. It's what to do when you've lost all of your devices, you're locked out, and you want to get back into your stuff, which in a traditional system is you message the system admin and they let you back in. If it's self-sovereign and self-owned, you need a key recovery story, and there's a bunch of ways of doing that, but there isn't there's no one right way of doing that today.
And just to add on top of that, I've heard recently that a lot of people have been losing their keys in boating accidents. So, if any of you plan to go on a boating trip, please don't take your keys with you.
Not your boat, not your keys.
Yeah,
That's true, Yeah, because you can fall in, you got your phone, you probably have your hardware wallet, because we all keep that with us all the time. And you're hosed, basically. Don't go boating. No, but there's, I mean, literally everything Brooke said is 100% right, and I probably don't even need to add anything. All the helpful hardware and browser, like sort of abstraction is just gonna get better and better and better. Losing your keys is a bad thing. I think there's a ton of really great human-computer interaction research that's happening right now around key recovery. Like, you know, if you forget something, you ask your friends for it. There's a pretty great model where you recover portions of your keys from your network of friends that you have. So there's lots of like ways to leverage being a human to actually interact with your keys and recover them and things like that. You also have more than one device. It seems pretty unlikely that you're going to lose all of them all at once, though not impossible. So like there's all of these different scenarios I think that are emerging as sort of useful best practices. And I'll stop there.
I mean, I don't really have anything to add, obviously, apart from just saying, yeah, the same. It's the human problems that are difficult, that element of the, you know, we can solve the technical, and one of the things, just to sort of shill this conference for a second, one of the things that I think is really good is seeing the level of use cases that are presented here as well, not just the sort of protocol streams and suddenly finding ourselves on a tech tooling panel.
I know this is dragging this question on a little longer, but I think just to like I think we've covered the technical aspects. Why are we doing the PKI stuff, right? We're doing PKI and foisting these conversations about keys onto users because this really hits at the heart of the sort of political aspects of why we're doing this, right? We're introducing this complexity. This is complexity that users are going to have to deal with on their own, but this is also an evolution of our online presence as people, and we're sort of saying, hey, in order for you to do this, you do have to actually reconcile with a new set of concerns, and we're going to have to surface a little more complexity to you because more and more of our lives are on the internet, and more of our lives are being tangled up in these interactions, and I think a lot of the like social reasons why we're foisting this complexity on you really does poke into HCI, because we're saying, hey, you need to contest with this, and this is part of the whole like reason we're doing all this to begin with. And that's why, you know, we say like, oh, this is just a UX challenge. Like, no, this isn't just a UX challenge. This is like a really crucial thing that we need to not only get right, we need to convince people of why we are doing this, right? Like, that's a really crucial thing.
And just to extend that a little bit, if you've shown a user a DID or a public key, you've already lost. It's already over. The people in this room care enough to get educated about these things. Nobody outside of this building does. 0%. People say that they care about privacy and security, and then they go and they use Facebook, right? Like, we have to make this stuff so easy to use that it doesn't matter that it's using the stuff underneath, and it happens to be secure, right? And by having that security and, you know, encryption at rest and all these things, we get all these other really great conveniences out of the system, but we still have to solve this hard problem of how do I, as a regular human being without a technical background, how do I, well, I mean, not literally me, but like, how would one do that?
Thank you.
Can I drag this question on for much longer? Yeah, it kind of reminds me, I used to teach journalists, investigative journalists, how to use things like Tor and VeraCrypt and things like that. And they couldn't get their head around things like, don't, you know, resize the browser, use different sessions, don't fucking log on with Facebook whilst you're in Tor, like all of these things. And there are, of course, people tracking what's going on with investigative journalists, and they don't kind of, they can't understand it. I don't mean to sound rude and patronizing, it just kind of shocked me. I'm like a semi-technical person, which is why I'm really weird to be on this panel, but people, safe space. But yeah, normal people that don't work in technology, they get terrified. It's like when me trying to do my tax return, it just, you know, and my mum's been in crypto for years. I've been in the space for like 5 or 6 years, and she still can't do anything with MetaMask without me sitting next to her, and that's a pretty easy UX. Like, it's hard, but yeah, like you say, once you've introduced these people to something like a private key or a public key, they're already self-selected themselves to be into it.
So we've spoken a lot about now, I think, with key management, about the sort of the HDI, the human device interaction aspect of it. I want to take this now in a slightly more technical direction, especially with a technology that I think a lot of us are very hopeful about. I know that some of you have either already interacted and used this technology, and some of you are building already tooling on top of it. So CRDTs. Underrated, overrated, why? Would love to hear your thoughts. Who wants to take this?
Can we first just prime for anybody who doesn't know what that acronym is? Can I do the
Yes, please do.
100,000 foot? Conflict-free replicated data types. The idea being a system by which you can deal with multiple people writing to the same thing. Fair? How do you deal with so the classic example is the Google Doc problem. You've got 4 people, okay, let's not use Google Doc, a collaborative document. And you've got 5 people, they all want to type into that same thing. How can they all type into that thing in a way that lets you arrive at a single and eventually consistent understanding that if everybody got all the same messages, we would all have the same view of the world?
Yeah, how do we do it concurrently, whether that means literally typing at the same time or concurrently where we were disconnected for some reason, now we're trying to reconcile our data.
Yeah, so where we're at with them, it's the only horse in the race in a lot of ways, right? We don't want to deal with it. I don't like complexity if I can avoid it, but this feels like the kind of thing that it's the best candidate that, in my view, that we have to get something like that. That live collaborative process is one really great use case. Just any time where you really have kind of non-blockchain synchronized stuff, CRDTs are really seem to be the thing that people keep turning to. The challenge with these for me, the biggest challenge here is the problems that we're trying to address and defining a really nice abstraction that application developers can build on top of. The problem you run into with CRDTs is it's really easy to make something that's consistent. It's really hard to make something that is actually does what users want it to do, right? We can write the math that says, yes, this will arrive at a consistent state, and we have a way for merging conflicting trees, but it'll spit out gobbledygook, and it doesn't really make sense. And so what we end up doing a lot of the time when we try to make this system for application developers is we have to figure out some clever way for them to express how to deconflict in that really edge casey scenario that actually happens a lot, where, hey, 2 people have made an update to the same sentence. How do we deal with that? And how do we come out with something that feels consistent and like a good user experience? I'm confident that the research is moving forward really well on the underlying tech side of things. I think the last piece of the puzzle that's going to be really hard to land is that how do I express conflict resolution as an application developer without exposing them to all of the guts of what it means to do conflict-free replicated data types across multiple parties.
Yeah, so I actually have some opinions here, and this might make the panel exciting, because I definitely think that CRDTs are a really interesting research topic, and I read about, that's my fun thing to read about. But in practice, they always end up falling pretty short of what I really need. So my team, we developed a database thing called ThreadDB, and it used CRDTs as a way to sort of lazily evaluate state on the node that needed to look at it. And we implemented this really complex framework that allowed you to express state materialization as a CRDT. And the one that got used all the time was an operational transform implementation. Which is basically where someone decides, sort of takes an update and sort of retransforms it to match the current state and blah. Anyway, it's the simplest possible sort of scenario. And then the other simple possible scenario that we saw 99% of the time was just, I will take the latest update, please. That's fine. I don't need anything more complicated than that, because it turns out semantics are very hard. My intention to move the word where from here to there it's really hard to capture that like intent and the semantics of that move. Like that's a complicated thing. But it turns out that like if I just take the next version where is now over here, it's fine. So like last right wins sort of semantics end up being quite expressive and quite fine. And so in practice, I keep reaching for CRDTs, and then I end up having to like build around them and make sure that I'm like sort of leveraging that way of thinking. And then it turns out it's just way more complicated than I end up needing. So yeah, it's one of these tools where I keep reaching for it. I think it's going to be great, and then I just don't need it, and it's way more complicated than necessary. As we get better, like local first sort of like applications, and we start to like smooth over some of that stuff, maybe that will get better. But like the best implementation I know of CRDTs is auto merge, or at least one of the most useful ones or usable ones, and it's not that usable, right? So like there's a lot of work that needs to be done on the developer's tooling side to make that better. And the sort of like, I don't know, embarrassing truth about CRDTs is that they're very use case specific. Like there's like so many different CRDTs out there. And if I want to work with text, I need one. And if I want to work with numbers, I need another one. And I don't want to think about that. Like I just have some data that I want to like, sync. Yeah. That's what I want. So unfortunately, I think a lot of developer tooling has to be developed in order to make that whole process a lot easier.
Strong agree, basically. So the things I'll sort of extend on that in addition, right? So CRDTs are solving the problem. How do we agree on a convergent state once we've made our own updates, right? Ideally, without user intervention, right? So it's like Git, but without the merge conflict part, right? They're relatively new in the grand scheme of things. People have been working on them longer than this, but the term was really coined in a paper in 2011. So we're at 11 years of CRDTs. There's very active research happening in them, and to be fair, like tons of research happening, but notice that I keep using this word research, right? If you're in a distributed system with an unknown number of participants, you can never garbage collect any of your state, right? And there are ways of compressing parts of that, right? But somebody could have a write that depends on something from 3 years ago. And now if you're doing this on a low-powered Android device, you've got to pull down all of this data to do the reconciliation, right? There's active research literally this year, in the past 10 months, on how do we do Byzantine fault-tolerant CRDTs. As far as I'm aware, Fission is the only team that has invested in encrypted at rest CRDTs where it has semantics at the encrypted and the decrypted layers. These are really foundational, fundamental things, right, that are like very, very new. And so just like, should you use a blockchain or not? Should you use CRDTs? Like, ideally not, right? If you have a single source of truth, if you have blockchain data, you don't have to worry about these things because you have consensus. And blockchains are one style of consensus. You can do lots of them, and there are trade-offs because consensus is slow because the speed of light is finite. If you want to have applications that are always online and never go down and where anyone can participate, yeah, you need CRDTs, but then you're taking on all the additional complexity today, and there needs to be better tooling, and there needs to be CRDT frameworks that come out with good standard libs, things like that. I'm just going to plug really quickly. It's not available for general release yet, but we're working on essentially a CRDT framework based on a database that comes with all of these things, that has incremental view maintenance, that does all of this stuff, and encryption out of the box, and has a standard library for these things, but it's coming out of a research lab, right? So there's going to be a lot of learning along the way once that is released and comes out. And even the guarantees that CRDTs give you are unusual, right? It's like, we may not see the same data because we have access to different data, and that might persist for years.
That was a hard question, Daniel. Good job.
Thank you.
Thank you for all the thoughtful answers. One final question. If you had a magic wand that you could sort of wave and solve one key problem in this space, what problem would you solve?
Identity.
I don't know yet.
Jack, can you expand on identity?
Thanks. Okay. Human identity. So something that would tie me, myself, who I know I am, to magic money that I have on the internet or magic data that I store or transport across IPFS. Something that isn't too hard for people to use but can be revoked, can be recovered, can be changed. Yeah, it's difficult, I guess, without going into, biometrics and scary stuff like that, but something that isn't too hard to lead us all to greater adoption, which I guess is what we want.
I got one if you want to marinate for a minute. Cross-organizational collaboration.
And all the tools and practices and things to do that. Yeah.
Just know what Textile's up to.
Yeah,
we're just brain linked.
I like that one. I like that one a lot. The truth is, all of the things that I find really interesting, I would hate to just wave a magic wand and have that done, because then I don't get to work on it anymore. So my answer would have to be something really boring that I don't want to do, so that I can just sort of not deal with that, right? So I like working on databases. Yeah, it would be something like that. It would be where my network stack just works. And so I know that if I publish some data, I will be able to get it on the other side or some peer. I think it's basically libp2p just ubiquitously works. Hole punching, everything, done. That would be, yeah. Yeah, exactly. Yeah, just some quantum stuff.
Just some quantum.
Yeah.
My original answer was actually also going to be cross-org collaboration, but I wanted to echo the questions about accounts and identity and just sort of broadly key management and recovery, which are really super hard problems that there are not good solved things for today, that we probably won't have good solutions for a while, and that once it's solved, it unlocks so many things, and the space can really just explode, which would be great. Cambrian explosion.
Single identity solution explosion.
Okay, I think we're coming to an end with this panel. I really want to thank all of you for participating. This was quite a thought-provoking panel, so give it up for our participants.